Hello everyone. Good morning students. I hope all of you are fine. In the last video, we have discussed about our topic vector, in which we have discussed about different kinds of vector, displacement vector, distance, velocity, speed, and basic difference between the scalar and vector quantities. In today's video, we are going to discuss a new topic in vector named as addition of vectors. You have studied about different types of vector. Now, today we will see how we can add any two vectors. What will be the rules or what will be the method to add any two vectors? So, our today's topic will be addition of vectors. So, our today's topic is addition and subtraction of vectors through graphical method. In this, we will see addition of vectors. First of all, we need at least two vectors just to perform the addition of vector on those vectors. So, we need at least two vectors. We can take more than two vectors. So, two or more vectors can be added graphically or geometrically by using two laws. What are the two laws? First one is triangle law of vector addition, while the second one is parallelogram law of vector addition. Now we are going to discuss triangle law of vector addition. As the name defines, there should be two vectors and the vector should be in terms of sides of a triangle. So we will see, like you can see here in the diagram, that this is vector A. Now you can take any vector B. These are not initially joined, but we will join these vectors according to our law of vector addition. If we will use triangle law of vector addition, in this we will see like these are the two vectors, A vector and B vector. Now we will fix A vector and we will move our B vector parallel to its initial vector. Like you can see, this dotted line is representing initial B vector. Now we want to join A vector and B vector. In that case, in triangle law of vector addition, we will fix A vector and then we will shift this B vector to the head of A vector. In triangle law of vector addition, what is the rule says that head of any first vector should be joined with the tail of any other vector. Like you can see here, we are shifting vector B parallel to itself, like its tail is joined at the head of A vector. Now you can see this is vector A, this is vector B. These two are the vectors which are joined head to tail. Like on this point you can see that these are head to tail joining. Now the resultant, how can we define the resultant? In triangle law of vector addition, the resultant is given from initial point, or you can say from the tail of the first vector to the head of the last vector. So here the tail is O point and the head of the last vector, that is second vector, that is R point. So our resultant vector is denoted from O to R, tail to head. So R vector is given to you as A vector plus B vector. So you can see in this expression that it is representing the addition of two vectors. And in this diagram OPR, you can see that it is looking like as triangle. So in this way you can see that when we add two vectors using triangle law of vector addition, in that the three sides will represent by the vectors, in which the two vectors are originally which we want to add, and the third side is represented by the resultant vector. So this is our triangle law of vector addition. This law is also known as head to tail method. What is this head to tail method? Why it is so? Because in this you can see that OP is the first vector, where P is the head of the first vector and PR is the second vector, where at the point where these two vectors are joining is point P, on which you can see that At the point P, head of the first vector is joined with the tail of the second vector. So at point P where the two vectors are joining, the types of joining is head of first with the tail of second. So you can see this is a method for head to tail method. So this is known as triangle law of vector addition, is also known as head to tail method. Now what you can see, the two vectors and their resultant form three sides of a triangle. So this method is also known as triangle method of vector addition. In this vector addition, you can see that the three sides of triangle is represented by the three vectors. Now next property, commutative property of vectors. In this property we will see that the resultant vector will be the same if in the previous slide we have seen that we had fixed a vector and we had shifted b vector parallel to itself, as the tail of a vector will coincide with head of b vector. So in this method, if we will fix the b vector, then what will be the next point? You can see that these are the two vectors, a vector and b vector. In this method we will see if you will fix b vector and then you will shift parallelly a vector, like you can see in the diagram. Again you can see b vector is fixed, a vector is shifting parallel to itself to the head of b vector will be joined to the tail of a vector. Now you can see again here b vector will be treated as first vector and a vector will be treated as second vector. So the resultant is given as tail of first vector is joined with the head of last vector. So this point is joining with this point, this tail is joining with this point. So this vector will represent your resultant vector. Now you can see this is OPR. OP is your first vector, PR is your second vector, and the resultant will be given to you from the tail of first vector to the head of second vector. That means R vector will represent, here initially vector B is your first vector. So you will write B plus A. B is your first vector while A is your second vector. So it will be B plus A. Now the second point is, in this you will see that you have fixed a vector and you will shift the b vector. Now we will check the resultant OR, that is a plus b. Now you can see in this diagram and in the second diagram, these are the two different diagrams in which we have fixed any different vector and we have shifted any different vector. So you can see the resultant is same in both the situations. So what you can say, like this is b plus a and this is a plus b. It means b plus a is equal to a plus b. So in this we can see that the resultant and the magnitude of resultant vector in both the situations is same. So you can see that b plus a will be equal to a plus b and that is equal to our resultant vector. So this above relation, what is this? R is equal to a plus b is equal to b plus a. This relation is basically prove that the vectors are commutative, or you can say simply commutative vectors are those vectors on which there will be no difference on changing the configuration. Like you can see, if you will write a plus b, you can also write b plus a. Both the vectors will be same in resultant, both in direction and magnitude. So such type of vectors are known as commutative vector. And what is this property? Let's see. The property that the vector addition is independent of the order in which the vectors are added is called the commutative property of the vector addition. You can add a plus b, you can add b plus a, both are the same thing. So this is your commutative property. Now we will discuss the next property of vector addition. This is your associative property of vectors. As we have seen on the previous slide, that vector commutative property is basically on two vectors, while the associative property will held on three vectors. Like you can see, a vector, b vector and c vectors are three vectors. First you have to fix a vector, then first you have to move parallelly B vector just like in previous slide. Then the resultant will be given to you, and that will be A plus B. In the triangle OPQ, you can see OA is first vector, PQ is B second vector, which you have shifted parallelly to original vector. Now the resultant is given to you A plus B. Now let's come to the third vector. Now the third vector is also added in terms of triangle law of vector addition. Like you can see, OQ vector will also treat again as a single vector. A plus B will give a resultant vector, and that will be a single vector. So this is the first side, this is the second side. So second side will be joined in such a way that C vector will be shifted parallelly to itself up to the head of the initial vector. Here initial vector we are treating as OQ vector. So the resultant again gives you OR vector. And the resultant will be what? First vector is A plus B and the second vector is C. So you can see resultant can be given to you A plus B plus C vector. This is your first situation. Now we will move for the second situation. Like A, B and C are the three vectors. Now you can see we will add firstly B and C. So we have fixed B vector and we have shifted C vector parallel to itself in such a way that the tail of C vector will join with the head of B vector. Now the resultant will be given from tail of the first vector to the head of the last vector. So you can see in the diagram that B plus C is given as resultant of the two vectors B and C. Now this is fixed vector. Now we will shift our A vector. Like you can see, A vector is here. We are shifting B plus C towards the A vector in such a way that head of A vector will be towarding tail of B plus C vector. Now this is your final term in which you can see A vector is your first vector and B plus C is your second vector, in which you can see that the resultant will be given to you as head of final vector and tail of first vector. So you can see in this diagram R is equal to A plus B plus C. So in both the results you can see that result magnitude is same and the direction is also same. So you can write R is equal to A plus B plus C is equal to A plus under root B, bracket B plus C. And this is the relation which is showing associative property of vectors. How can you define the two vectors? This is the associative property of the two vectors. Like you can see in this, these two diagrams are consolidated in a single diagram. You can see like when you will join A plus B first, then the resultant will be given to you A plus B, then finally C vector will be joined to, it will also give you A plus B. And if in the three vectors, if you will join initially B plus C, then the resultant will be given to you B plus C, and then you will join this B plus C with the A vector and the resultant will be given to you A plus B plus C. So this is your associative property of vectors. Now our next method for joining the two vector is parallelogram law of vector addition. In this law, what we will see that the two sides of two vector will be represented as the two sides of a parallelogram, and these sides will be adjacent sides. Like you can see in the diagram that here A vector and B vector are given to you. In this tail to tail you can see like this. Now we will draw parallel vector to B vector joining from head of A. Like you can see in the diagram, this is OR vector. Now this is RP vector. Now the resultant will be given to you by the diagonal of this parallelogram, and the diagonal passing through the O point, or you can see passing through the coincident point of the two vectors through the tails. So this vector is given to you A plus B. Both the vectors will give you the same result, but the method is different. In parallelogram law of vector addition, you will add two vectors by the two adjacent sides of a parallelogram. Then the resultant is represented completely both in magnitude and direction, because a vector is having